This is devane.clarke at the University of Texas at Dallas with the UT design team. Today is Saturday, October 27th, and we are disassembling and reassembling a small single-stage cycloidal drive reducer. And Jonathan, if you'll describe what you're doing as you do the disassembly.
Okay. First bit is just getting these Allen head screws out of the housing. Separate the two major parts. Okay, and remove housing from the cover of the outlet shaft.
That exposes the roller pins for the output.
In order to remove the gears, it's easiest to remove these first.
How many total, do you know?
21.
21 total?
Yes, sir. Okay, once the ring pins are removed, it's just a matter of lining up the input shaft set screw. There. I can remove the output shaft. There's some loose ball bearings here. There, then take off the shaft collar. Gears come out and they separate. And that's pretty much it. From here it's just the input shaft and the bearing housing.
And it's an eccentric bearing, correct?
I believe so, yes.
Okay, can you turn it over and let me see the input shaft? Okay, good. And as we discussed, the gears themselves are laminated construction.
They are, and they're offset by 180 degrees from each other.
Okay.
With
Perfect. Now if you'd be so kind as to put it back together again. In terms of materials of construction, does all of this appear to be stainless steel to you with an aluminum housing? Or is it, do you think this is mild steel?
that I'm not entirely certain.
I did not bring a magnet with me, so I don't know either right offhand, but we'll figure that out.
It's just a matter of reinserting the ring pins, but prior to that, I like to line up these holes for the output shaft.
And we'll need to put the bearings back, rest of the bearings back in too. Have you determined the reduction ratio yet?
We have, it's 20 to 1.
20 to 1, okay.
And so far we're under the impression that the 2 offset gears are to prevent dynamic vibrations. But that's going to be something that we really determine whether or not that is the case whenever we do the kinematic analysis.
Very good. Can you go ahead and spin the gears without the output shaft attached to show how they engage?
Okay.
Just rotate it by hand a little bit. There you go. Thank you. So you're rotating it from the input side, and we're looking at the output side.
As you can see, the eccentricity of the center of rotation causes the cycloidal gears here to be pressed against the ring pins and to rotate along them, which is actually where you get your gear reduction.
Excellent.
Of course, that is also dependent upon these rollers and how they move concentrically inside these holes here. We'll have to figure out a better way to seal these bearings.
That's the tricky part, is to keep the bearings in place while you assemble the 2 components. It looks like there's one more bearing. In terms of lubrication, you think it's lithium grease is the lubricant for the prototype?
Yeah, I would say so.
It's just the grease that holds the bearings in the race.
I'm going to line up. There's one side that has 2.
assembled and disassembled in exactly 11 minutes. Thank you very much.